Please welcome Marc Blackmere to the S4 main stage.
Thanks. Good afternoon. Now what we're going to do is talk about this project that we're working on. And what I want to emphasize is this is not about a Cisco product. This is not something that we want to sell. It is an approach to looking at IoT security. And really what I'm here to do is A, give you an update, tell you what it's about, and number two, invite your participation in the whole process. So I wish I had time to, now I'm realizing I should have had a spoon, a spork, and a fork up here. It might have helped translate this picture a little better. But when we're looking at the IoT, we kind of see it in three main areas. So you've got traditional IT, data centers, mobility, cloud, the stuff that you'd expect. Of course, OT, I don't need to define that for this crowd here. And then the CT aspect of it, which is consumer technology. So we think connected home, Fitbits, all that kind of fun stuff. And I'll probably be more focused in the IT CT space. Maybe we'll talk about OT a little bit. But I just at least want to level set there. And I think when we look at IoT security, there are two main things that stand out about IoT to me than other realms of security. I think in some ways what we're seeing with the IoT is just more of the same. When we look at security, I'm a big believer in foundational best practices, for example. But I think there are two distinct things that set the IoT apart. Number one, connected does not equal smart. I try not to use the term smart when I refer to these devices because they're anything but smart. What I see them are as vulnerabilities. I see them as attack vectors. So that's problem number one. The next issue I see is really around, let me expand on that a little bit, because when we're looking at these devices, you know, the idea of should you connect it? Just because you can doesn't mean you should. Do we really need these things connected to the internet? Do we need light bulbs that are on there? Do we need health monitors, baby monitors, things like that? Do they really have a place there? But what I would say for those of us in this room who focus on security, really the idea is just irrelevant. It's going to happen. People don't care. Well, that's the jaded side of me speaking. I think that there are great benefits that come from this connectivity. If they weren't there, we wouldn't have them. But the reality of it is really just everything's going to get connected. We're going to keep seeing it. And for us as defenders, that's just our reality. So the next thing that I wanted to talk about, too, is scale. So I think that is one thing that is unique to the IoT, is just the sheer scale of what's being connected. Gartner estimates that there will be 20 billion connected things by 2020. We at Cisco estimate there'll be 50 billion connected things. But I think when you're a network administrator, when you're on the security team, it really doesn't matter which number turns out to be correct in the long run. You're dealing with a scale like we haven't seen before. It takes up a lot of time, it takes up resources, that costs money. And then of course too, really complexity is the enemy of security. So those are the hallmarks that I see here. And we can talk a lot about the manufacturers of these devices, how mature they are from a security perspective, what their intentions are. I don't know if any of you have seen that. The FTC is actually going after a maker of connected devices, saying that they had misled customers as to the security of those devices. So we do have that element to contend with. But there's the reality of what manufacturers are up against. They are in a commercial market. They do have price pressures, competition. Many of these devices, of course, are commodity devices. So can they even power what would be needed to run any kind of decent security? So aside from the security maturity end of things, there are just some realities that make defending these things and securing these devices almost impossible. And so when we're looking at that too, even if a device is quote unquote secure, how long is it secure? Let's just even forget about the definition of what secure means. How long is it going to be secure? And again, from a connected device perspective, look at the sales model, for example, on Android phones. Not to pick on them, but I like to look at the business model. And really, handset makers are the ones putting the phones out there. So they make their money by selling handsets. So if a device, actually I have a tablet at home that I bought, and I realized that vendor never, ever, ever pushes out updates. So what I did is finally when I realized that, I let the battery run out, I put it away and moved on because I don't want that in my home. But that's what we're looking at. So the thing is, you have a device, it may be secure in the beginning, it goes end of support, but you're gonna use it a lot longer. And so when we look at that across IoT devices, connected devices, we have a problem with a timeline of devices remaining in use, but insecure. So now that I've filled you all with shiny rainbows and unicorns about the state of things, what can we do about it? How do we fix that? And that's the thing that we're here all to talk about. And is it going to take standards? I hear people talking about the need for new standards. I'm of the opinion they're great. Actually, my background in security is around SIM. So pulling in multiple data sources and trying to normalize data to make sense of it. So I appreciate standards. They do have a place. The IoT is just so vast, so different throughout that whole continuum, if you will, that no one standard's going to work. So we'll have them. They make sense. I see it from an interoperability perspective, but really, not so much on really helping security all that much. On the regulation side, this is where my libertarian tendencies come through. I tend to view regulations as a symptom that we in the private sector have failed to regulate ourselves. So they do have their place. Actually, at lunch, I was chatting with somebody about how NERC SIP actually really helped them improve their network. It allowed them to standardize under the guise of SIP. So I get it, they do have their place. And I think when we look at things like I mentioned the FTC case, I think that makes a lot of sense when they prompt companies to do the right thing. But for me, they're not the be-all, end-all. So we get to thinking, and by we, I mean a bunch of other people at Cisco who are smarter than me. And we get to thinking, so instead of just really trying to reshape the world, what if we took a look at using existing standards, using things that are already there rather than trying to really just reinvent the wheel? We don't want to do that. And then what if we leveraged subject matter expertise in the different areas of the IoT, so around networking, around the devices themselves, from the administrators, in order to kind of spread out the security, distribute security, if you will, to those areas with those people with subject matter expertise. And so that's what we did. So the idea around MUD, manufacturer usage description, is that we look at network security vendors as experts, should be experts, in that world. Device manufacturers, they're going to know what their devices are meant to do. They know how they're supposed to communicate. That's their area of expertise. And then the network administrator will know what is appropriate for that environment. So we looked at a way to kind of break this out amongst those three pillars such that we use those together and then create a really, I guess, more secure environment. So the way it works is like this. So if we take, we have our intended communications. So anywhere on a network, we know what is supposed to happen. We know what we want to have happen. But the reality of it is, you look at something like this, is great. This is the whole thing about the IoT. I mean, you've got, say, a doctor in a remote place, and they go through some cloud-based app that goes back to the hospital, and they do all these great and wonderful things, and everybody's happy, and there's rainbows and unicorns. But the reality of it is, we don't know what's going on. Many of you here are consultants. Many of you here work in the field. So you know that a lot of times when you're working with a customer, maybe even in your own environment, that you have what's intended to happen, what you're trying to do, and then actually what is going on. And so we don't always know what that is. And so we're looking at it from a perspective of, we think the network is the right place to mitigate that kind of unintended consequence, if you will, unintended communications. And this is where the manufacturer usage descriptors come in, or MUD. So being able to work that into the network. And so here's how it works. So the idea is, in this case, if we take a DHCP environment, so we've got our light bulb here. So it's going to be looking for an IP address. So what we're proposing as a change to the DHCP standard is just one extra field. And what happens in that field is when this device requests an IP address from the controller, that field will contain a URI. And it's going to look something like this, where it's going to go out to its manufacturer based on the manufacturer's website, the model and version number of the device. And what it's going to do is we'll take that URI, and then the network controller will go and query the website of the manufacturer to pull down that file. And so what we see next then is then the manufacturer just returns with the file. And here's a sample MUD file. So basically it says, here's what that device is, here's what it should do, it'll contain some other information, but we're then able to take that, bring that in, and look at a more detailed config. And so within the network itself, basically it's working on the idea of, okay, what does the file call out specifically? This device can do X, Y, and Z, and then pretty much anything else is implied as not being allowed. So that way we have that in, it comes into the access list, and now we have policy on the network. And so, and that, by the way, too, the network administrator is the final arbiter to say whether or not this policy will be instantiated in their environment, because they know their network the best. But what the end result here is that you get basically putting devices in their own swim lanes. So that way we're mitigating the possibility of those being used for being used as access points, the kind of the toehold in the network, trying to prevent that lateral movement from a device talking to other devices. And so one of the things, when this was first presented to me, first question I had around it was around the security of it itself. And so this is one of the reasons too we're looking for assistance that I'll get into more. But in the DHCP type of environment, we have to trust the device that's making the request that it is what it says it is. We can see working in some measures to prevent that, but when we're looking at say an 802.1 AR type of environment, then we're able to work with signed certs so that we have a better chance of showing that, or that there's proof that the device and the manufacturer say who they are. That way there's a higher level of confidence when the network administrator pulls this information in. So we're not pitching this concept as the be-all, end-all. This is not one of these things where we say, once MUD comes to life, you can throw everything out and you just need this one thing. That is not at all what we're saying. We're looking at creating a standard here that is another level of defense in depth, so it complements existing technologies. We're not really trying to replace anything. We're trying to augment. And again, as I mentioned, the idea here is to prevent lateral movement. So you see a lot of attacks where that is. You just find something in the network that you can get on and pivot from there. So we're trying to block that. I think if you think of the Mirai example, the idea that why would my IP-enabled camera be trying to go to a particular writer's website? That's just doesn't make sense. So just that kind of idea that just explicitly being able to say, no, this only talks to its controller, thereby blocking that type of behavior. And then really it's about the scale. How do we conquer the scale? I've certainly seen customers who had to go around and find rogue access points, for example, on a large campus, and they would just go building by building, floor by floor, section by section, just trying to find devices that they knew were on their network but they didn't know physically. So the idea here is that the administrators aren't going out having to physically find these things, that it is actually MUD helps them take care of that. Now, what it doesn't do, this is not an authentication method, so devices that are on the network would be authenticated through any existing measures. Now, MUD was not intended to replace that. And really, it's more about keeping the devices in their swim lanes, not so much about, if something's already popped, we'll keep it in the right direction, but it's not really so much a tool to replace an IPS, for example. Now, the other thing that where we see it too is actually where would deploy this. Again, we don't see this being deployed for every type of environment. Certainly in the healthcare industry, with those types of devices, we think it makes a lot of sense. We're looking more in dynamic types of environments where things change on a regular basis. Do I see this out in a substation? Maybe not. But then again, we've had some people come back to us with some use cases that we had never considered before because we had a specific idea when we went out. It's one of those things sometimes where somebody will surprise you and go, oh, hey, let's use it this way, and we hadn't thought of that. So the benefit that we see for end customers, again, is that savings in effort. So really that's an OpEx type of thing. So you don't want your team of well-paid administrators and engineers running around chasing rogue access points, figuring out where all the connected light bulbs are, figuring out how they behave, all the things that go with what's now connected to a network. The idea is to stop having them do that, or at least really cut that down. So there's definitely an OpEx perspective to this. We're also, where we're pitching this or trying to make this a new standard, the idea is to not throw out everything that's already out there. A rip and replace of existing infrastructure is not realistic. It just won't happen. You're still going to have dinosaurs on the network. They may have a service to a use on there. So we're not talking about a complete rip and replace. If anything, it's a software update. And in the case of 802.1 AR, there's actually wouldn't be any coding changes really needed. It would be probably more on your network security provider to support the standard. For the manufacturers of devices themselves, that also gives them the opportunity to focus on their devices. Really, I'm not going to go there. I'll go there over here. I think you know where I'm going. I know some of you are telepathic. You've heard me rant. But no, the idea here being that they can focus on doing what they need to do because either A, they can't build security into these things, they won't build it well into these things, or they just don't care. So that kind of removes that off the table. It's just basically creating this file. So what's next? So why am I telling you all of this stuff? Well, it's because this is an open approach. It's an open standard that we're looking to create. We are with the IETF now to get that DHCP update finalized and blessed and all that kind of good stuff. So that's in progress now. We are looking for other organizations to help us refine the RFC. We really don't want this to be a Cisco-only thing. As I mentioned, this is more of a community thing. We're looking for input from others for use cases we never thought of. Especially in the security community, we want you to poke holes in it. We know it's not perfect. We're not claiming that it's perfect. We like to think we've gone through a bunch of scenarios, but the more holes that can be poked into it, then we can start filling those things and it'll be that much better. There is online, if you want to check it out, I know this is going to go on YouTube, so I didn't put the URL up there. Come see me. You can actually create your own MUD files. One of the architects who came up with this stood up a server where you can create your own MUD file so you can see what the process is like and what the output is like. So just feel free to come see me later, and I'll give you that URL. And then really the last thing, if you're interested in getting involved, if you have more questions, certainly I'll do what I can while I'm here. But you can email us at mud@cisco.com. And that goes directly to the architecture team that is working on this right now. So we are really looking for that kind of input. We've had some from some pretty major players, but again, we're trying to really broaden who gets involved so that we really are more representative of what the community needs. So on that note, that was the last one that I had to talk about. So just really to summarize, again, please see me afterwards. We really would love to have your input on this and your participation. And then also while we're here, there's a couple other things, because we're not just done with this. Tomorrow we have our Cabana session, and there is the kegerator. So I don't know how many hands are out there, but if you're not familiar with the kegerator, also known as APT, or Advanced Persistent Thirst, what it is if you can hack through the ICS that controls the handles on the keg, you can pour yourself a beer. So it is literally hacking for beer. So there's that tomorrow at our Cabana session. And then I'll have a session in the sponsor stage on Thursday called Mentoring for Fun and Nonprofit. And we'll talk about the work, my nonprofit work with Interrupt and how you can get involved potentially with that and helping kids learn more about ICS. So with that, I'm a little ahead of schedule, but thank you very much for your time, and I hope to talk to you guys some more. So thank you very much.